Hey, everybody. Welcome back to Soft Spoken Scientists. I'm glad you're all here today. So, today we're doing empirical and molecular formula problems exactly like general chemistry exams. I'm going to solve multiple practice problems, show every step, and explain why each step matters. If you follow the same process, the numbers can change and you'll still get it right. So, empirical formula is the reduced ratio. Molecular formula is the real formula. We always find the empirical formula first, and only then, if a molar mass is given, we scale up to the molecular formula. Okay, this is the 6 steps in order to do it correctly. If you have a percentage, assume 100 grams. You're going to turn grams into moles for each element, divide all the moles by the smallest, and when we do a practice problem, all of this will make sense, I promise. We're going to fix decimals by multiplying to whole numbers. We're going to write the empirical formula. If a molar mass is given, I'm going to find the molecular formula, M for M. This is the exact same workflow for every problem. If you don't skip steps, you don't get lost. Okay? So, they told us in this practice problem, a compound is 40% carbon, 6.7% hydrogen, 53.3% oxygen. Find the empirical formula. So, we have carbon is 40 grams, hydrogen is 6.7 grams, oxygen is 53.3 grams. I knew this because I just turned them into grams. That's all I did. Because percent means per 100. Assuming 100 grams turns each percent into grams instantly. I'm going to write out the molar masses. And this is something you can get in your periodic table, and I'll write it in purple. Carbon is 12.01 grams. Hydrogen, 1.008 grams. Oxygen is 16.00 grams. Okay, that's from the periodic table, so you can reference that. Now I convert grams to moles because formulas are based on atom counts, and moles track atom counts. Okay, let's start with moles of carbon. Okay, I have 40 grams, and I know that because they told me that. Divided by 12.01 for each of the carbons. You do that on your calculator, you'll get 3.33, you guys. Let's do moles of hydrogen. I'm going to take the one that was given first, which is 6.7. And that is a terrible decimal point. And I'm going to divide it by the atomic mass, or molar mass, you could say, 1.008. And I get 6.65 on my calculator. I'm going to do it for oxygen. Moles of O equals 53.3, my given, divided by 16. And I got 3.33. So if you notice, the molar masses kind of go down here. You see the trajectory, MM for molar mass. All right, I think you guys do. Okay, so now I divide everything by the smallest mole value because I want the simplest ratio. So I'm looking at this, whether we're talking about moles of oxygen, whether we're talking about moles of carbon, it doesn't matter. I know that 3.33 is the lowest amount listed among the 3 options. So I'm going to divide by 3.33. Okay? To all of them. Just bear with me. Again, now I divide everything by the smallest mole value because I want the simplest ratio. I can't express that enough. So for carbon, we got 1. H, we got 2. And then for oxygen, we got 1. Just combine it. You got C1, H2, and then O, 1. But it's weird to include ones. Ones are not written, so it's just CH2O. Ones are invisible. Ratio is 1 to 2 to 1. So the empirical formula is CH2O. Good work, you guys. Let's try, and again, with practice, you guys will be rock stars. Okay, a compound is 27.3% carbon and 72.7% oxygen. Okay, find the empirical formula. We got this. So we're going to assume 100 grams. This is just 27.3 grams, 72.7 grams. They're just trying to scare us. Now, I'm going to start with moles of C, because step 2 is to convert to moles. 27.3 divided by 12.01, which is given. This is the molar mass on the periodic table. That's 2.27. Let's do moles of O. 72.7, that was given to me, divided by 16.00, which is the molar mass on the periodic table. And I get 4.54, right? Now, we convert grams to moles for each element. Step 3, divide by the smallest. Which one's smaller, you guys? 2.27 or 4.54? 2.27 is obviously smaller. So divide both of them by that. And you get for C, 1. And then for O, you got 2. Okay? So, because 4.54 divided by 2.27 is 2. Okay? Now, I'm going to say, okay, I have C1, O2. Do not include your 1s. So it'd just be CO2. Clean whole numbers, no fixing needed. So this is your empirical formula. And we're going to do harder ones as we go on, I promise. So a compound is 50% carbon, 6.25% hydrogen, 43.75% oxygen. Find the empirical formula. Step 1, you guys, assume 100 grams. So carbon is 50.0 grams. Hydrogen is 6.25 grams. And oxygen is 43.75 grams. I just giggle because it's a little tedious, all this work you guys do, but we got it. So you got 50. Let me just write it a little nicer. You have moles of carbon, right? Because you got step 2 is to convert to moles. 50.0 divided by 12.01. This is the molar mass of carbon that's on a periodic table, which would get you 4.16. There you go. I had to add that. Now, let's do moles of H, because they gave us that. So they gave us 6.25 divided by 1.008. This is a molar mass you'll get on a periodic table. By doing that division, I got 6.20 on my calculator. Now I'm going to do moles of oxygen. 43.75 divided by the atomic mass of oxygen, which is 16. And that got me 2.73. Now I divide by the smallest to get a ratio. Which one's the smallest among these 3 options? Which one's smaller, you guys? 2.73. So divide all of them by 2.73. Okay. So 4.16 divided by 2.73 is 1.52. This 6.20 divided by 2.73 is 2.27. And then 2.73 divided by 2.73 is 1, right? I don't stop here because 1.52 and 2.27 aren't whole numbers. Exams expect whole number subscripts. So now we fix the decimals. So I'm looking at this, and this is what I have. It's a little rough, right? I got like 1.5, and I got like 2.27, and I got a 1. Okay? So let me think about this. You got it so you have this right now. Let me write it out so you guys know what you're really up against. Okay? I'm not going to write the 1. So this is what we have, right? C 1.52, H 2.27, O 1. Okay. Ask yourself, what can I multiply these two by, or everything by specifically, to get rid of these weird funky decimals, right? So if I multiply by 2, I know 1.5 times 2 is 3. That could work, but 2.27 times 2 would be like 2.56 or 54. That's still a decimal, so I know that's not going to work. Let's try 3. 1.5 times 3 is 4.5. That's not going to help. That's still a decimal. What if I multiply by 4? Well, I know 1.5 times 4 would be, I know that would be 6. Okay, I had to do a little math there. So 6.0 specifically. And if I did 2.27 times 4, I would get like 9.08, which is roughly 9. So guess what? That'll do. So what I'm going to do is I'm going to multiply everything by 4. 1.52 times 4, that's 6.08, which is roughly 6. Okay, and let me just show you this real quick. If I do that little squiggly line and I say like 6, this means approximately. So don't let that scare you if you see that symbol in lab or something. All right, so you have C6. I multiply the H by 4. And I got, again, 9.08, and it's roughly 9. So it's H9. And I got this invisible 1. What's 1 times 4? 4. So after scaling the ratio to whole numbers, the empirical formula is C6H9O4. Let's move on. This one's a doozy. Empirical formula is CH2O, and the molar mass is 180 grams per mole. And they said find the molecular formula. Molecular formula problems always start by finding the mass of the empirical formula. So let's do that. So CH2O. C is 12.01 on a periodic table, plus 2, that came from here, times their atomic mass of 1.008 plus 16.00. So this is like 12 plus 16, that's 28. 2 times 1.008 is like 2, so 30. So 30.0 grams per mole. Okay? Now, we have to do our multiplier. So we have to take this empirical formula into, have it as a molar mass divided by the empirical formula. So we have 180 divided by 30. And by doing that, you get 6. That's our multiplier. So 6 is your multiplier. This number tells me how many empirical packages fit into the true molar mass. So we had C6H12O6. You see what I did, you guys? What's 6 times 1? 6. What's 6 times 2? 12. What's 6 times... Well, 1 times 6 is 6. Remember, there's an invisible 1 that they don't tell you about. That's the molecular formula. Multiply every subscript by 6, and that's how you do it. Let's try this one. A compound is 52.2% carbon, 13% hydrogen, 34.8% oxygen. The molar mass is 92 grams per mole. Find the molecular formula. That is a lot, but we got this. So we're going to, same thing, assume 100 grams. So this is, we're going to say 52.2 grams of carbon, 13.0 grams of hydrogen, 34.8 grams of oxygen. Percent to grams is automatic once I assume 100 grams. Okay, and again, the molar masses, so we'll have to do that again. So moles of carbon is 52.2 grams divided by 12.01, the atomic mass. And that got me 4.35, and 12.01 came from the periodic table. Now, let's do moles of hydrogen. Oh, okay. Moles of hydrogen is 13, that was given, divided by 1.008 from the periodic table. It's 12.90. Moles of oxygen. You got 34.8 all over 16. Because each oxygen's atomic mass is 16, which is 2.175 on a calculator. I'm keeping a few decimals because ratios depend on accuracy. Now, step 3, divide by the smallest. Which one's the smallest? 4.35 or 2.175? 2.175 is smaller than also 12.90. So divide everything by 2.175. And by doing that, I got 2 on my calculator. I got 5.93, and then I got 1. Now I check. Carbon is basically 2, oxygen is 1, and hydrogen is 5.93. Very close to 6. On real exam data, small rounding happens from molar masses and percentages. If a number is extremely close to a whole number, we round to that whole number. So we were given C, H, and O, right? So we got C and H and O. So we got C2, H is 6, and then we got 1 for O, which is just written the way it is, like that. So the empirical formula is C2H6O. Now, find the empirical formula mass, which is important. Okay, so let's find the masses of it. We have 2 carbons times 12.01 plus 6 times 1.008 plus 16. That's from the periodic table. Okay, so when I plugged that all in my calculator, I got 46.07 grams per mole. Now let's say hypothetically you didn't get a calculator. What's 12 times 2? It's just 12 plus 12, 24, right? What's 6 times 1? 6 plus 16. Well, I know 16 plus 6 is 22. I know 22 plus 24 is like 46. It is 46. So 46.07 grams per mole, all right? So now I compare the given molar mass to the empirical mass to see how many times bigger the real molecule is. So I have 92, this is given to me. Oh, I got 92.0 grams per mole. 92.0 grams per mole. I don't even need to include units. That's just being fancy. Equals 46.07. All right. That equals 1.997, which is around 2. The multiplier should be very close to a whole number. Here it's basically 2. So I have my molecular formula, and now I have to multiply everything by 2. What is 2 times, let me use a different color. What is 2 times 2? C4, because 2 times 2 is 4. What is 2 times 6? 12. What is 2 times 1? 2. All right? Multiply every subscript by 2, and that gives the molecular formula. So C4H12O2. And just a quick reminder, you guys, like if I said C6, this is a subscript. And then if I'm like, oh, 10 to the 32nd or something, if I raise to something, that's an exponent. Just be super clear about that. Okay, the key to these problems is not memorizing at all. Please don't memorize. That'll lead to a disaster. You need to just practice it. And I really would suggest like getting a few bright colored pens like aqua. I think you guys know I like aqua. Blue, just happy colors, right? And just practicing it, using the the practice problems your teacher and professors give you, using the book, my channel, of course. Just practice makes perfect. I'm telling you, this is nothing you can memorize. You know your steps, and then you got to practice applications of those. It's following the same steps every time, you guys. Assume 100 grams, convert to moles, divide by the smallest, fix the ratio, and then scale up if molar mass is given. If this helped you, please like and subscribe. It would mean the world to me. And remember, STEM is for everybody, especially you. Keep at it.